You are not audible, madam. Shweta, madam.
Sir, am I audible, sir?
Yeah, now it's okay.
Yeah. Good afternoon, everyone. I invite all the participants back to the post-lunch session of third day on 3D printing and design. On behalf of the organizing committee, I take the privilege to invite Dr. A. Manmadachari, sir, for session 8 on online practice session on Bio-CAD modeling using 3D slicer and CURA slicing software. Dr. A. Manmadachari, sir, is presently working as Assistant Professor in the Department of Mechanical Engineering, ICFI Tech School, IFHE University, Hyderabad. Sir completed his PhD from the National Institute of Technology, Warangal, in additive manufacturing. He completed his Master's in Production Engineering from the University College of Engineering, Osmania University, and BTech from JNTU, Hyderabad. His areas of interest include 3D printing, optimization techniques, CAD/CAM, design and manufacturing of patient-specific implants. He has published more than 30 papers in various referred international journals and conferences. He completed R&D project for Institution of Engineers, India. He received MEDIC 2018 Innovation Award from Indian Institute of Technology, Bombay. He has filed a USA patent on implantable device for temporomandibular joint and method of production. He is a life member of the Institution of Engineers and American Society of Mechanical Engineering. He is an editorial board member for the Journal of 3D Printing and Additive Manufacturing. He works with MNR Medical College and Hospital, Paninia Institute of Dental Science and Research Center, Ozone Hospital, LB Nagar, for solving various critical cases through design and manufacturing of implants. I welcome you, sir, and hand over the session to you for the presentation. Sir.
Thank you, madam. Thanks for your nice introduction to me. Shall I share my screen, madam? Is it visible my PPT, madam?
No, sir, not yet. You have started sharing the screen, but the PPT is not yet visible, sir. Yes, sir. It is visible now.
Okay, thank you, ma'am. Thank you. Okay, today now I'm giving a demonstration on Bio-CAD modeling. Okay, how we are going to develop a Bio-CAD model with using the 3D slicer, and we are going to develop a slicing models. That means after converting the STL file, we are going to develop a slicing data. That slicing data we are giving the additive manufacturing machines here. In this session, we are going to practicing two softwares. One is the 3D slicer and another is a CURA. With using these three softwares, we are going to develop a Bio-CAD model, as well as we are going to develop a G codes or whatever the slicing software or slicing models are required. That slicing models we are going to develop with using this CURA software. Already you know the rapid prototyping and additive 3D printing and additive manufacturing, solid free from fabrication. They all are the synonyms. Here in the rapid prototyping and 3D printing itself, the name itself is telling it is a prototype and it is a 3D model. In the earlier days, these 3D printing technology and rapid prototyping technology, they are using only for the prototype purpose only. They are looking purpose they are used. Nowadays, we are using for the functional parts. So that's why this is present as an additive manufacturing. Okay, the Terry Holder, he's given a definition about the rapid prototyping. It is a technology to produce your parts and models from 3D CAD model data and CT or MLS scan data and medical data created from 3D object digital systems. Here we are going to develop a model from the CAD. Here we are going to develop a model from the medical data. Here we are going to prepare a data from the 3D scanning data. With using the CAD, with using the medical data, with using the 3D scanner, we are going to develop a model in 3D printing and rapid prototyping. Okay, here now we are using the functional parts. So that's why this is considering as a manufacturing process. So that's why we are telling as an additive manufacturing process. Here, I already that we are going to subtract to the in the subtract manufacturing process. We are taking the one component, and that component we are going to remove the material. Whereas in the additive manufacturing process, we are adding the layer one upon the other to make a component. Here, from the territorial definition, we can conclude we require the 3D CAD data or anything. Okay, we require the CDR MS scan data, and we are require the 3D digital object system. That means 3D scanning system. How we are going to develop these models, which is useful to the 3D printing software or the 3D printing machines. Always the 3D printing machine, it is taking only STL file only. Already you know, okay, might be okay, those who are studying the Ian Gibson book, additive manufacturing textbook. Okay, this is a flow chart. How we are going to develop a components with using the additive manufacturing process. Okay, this is a sequence of the steps. First, we are going to take a CAD model. Okay, this is how to develop a CAD model, the computer design. Okay, here nowadays so many softwares available. Okay, from the CAD, okay, from the softwares we are developing the CAD. That CAD model we are going to convert the STL file. When we are converting the STL file, the totally surface is going to tessellating by the triangles. So that's why this is called as the standard triangle language or standard tessellation language. Some people they are calling as a stereolithography file. Okay, who is this first initially this is used for the stereolithography operators machine. So that's why they are representing as a stereolithography operators file. Okay, the totally triangle is tessellating on the surface. That's why they are calling as a standard triangle language or standard tessellation language. Here we are using the triangle for making a tessellation. So that's why this is called a standard tessellation language or standard triangle language. All are the same. In this STL file, once after completing the STL file, this STL file we are going to convert the data which is read the machine. How we are using in the computer the binary digits, binary numbers. Here also, okay, it directly the machines is not reading the STL file. It is reading only layer information. So that's why once again we require the softwares to convert the file that file is readable to the machine. So here we require some slicing softwares is required here. Once okay, after slicing this one, we are giving some machine setup. Okay, whatever the machine setup is required here, how much temperature is required, how much speed is required, all these things we are going to giving in the machine software here. Okay, whatever the inputs is required, that inputs we are going to give in this 3D slicing software, 3D printing software. So after giving all this information, all the data, then we are going to convert the layer information from this STL file. That layer we are sending to the machine. Then the machine is going to manufacturing a component. Okay, after manufacturing the component, we are removing the component from the machine. Then we are doing some post-processing. That means we are going to remove the support structures. Then we are going to use for our function, our application. Here now you can see up to first stage and second stage and third stage, fourth stage, up to this one here, we require the softwares. Without software, we can't do anything in the 3D printing. So you have to develop a CAD model, whatever the function, whatever the model is required. First, you have to develop the CAD model. Okay, then you have to convert the STL file. That STL file you have to open in your 3D printing slicing software or 3D printing softwares. Nowadays, okay, each 3D printer, they are providing their own softwares. But almost all the basic operations are the same. The features are different here. Some small difference is there in the features, but the process is same. Then here we are adding all the information, whatever the material information, whatever the parameters are required, all those things we are going to set up the 3D printing software. Then that file is sending to the machine. So here up to now we require the softwares. In this one, okay, today I'm giving a demo on how we are going to develop a STL file and with various techniques, with using the CAD model technique, with using the CTR-MI technique, with using the 3D digitization systems. Okay, that is we are going to learn. Then after developing STL file, we are going to transfer a 3D printing software, and the 3D printing software, okay, we are going to do the slicing. We are going to develop a support structures. We are going to give you input parameters, whatever the machine input parameters is required, that we are going to give. All those things, how we are going to do that, you can see in the 3D slicing software in the CURA. That I'm going to deliver yet delivering in this session. So how now you can see here when I'm this 3D printing process, okay, when I'm dividing as a pre-processor and post-processor and processor. Here in the pre-processor, we required all the softwares here. With using all the softwares, we are going to develop a data. Then in the processing, we are going to manufacturing a component. The post-processing, whatever the support structures are there, whatever the post-processing techniques are there, that is we are going to do here. In the pre-processing stage, we require the design. So that's why the design is very, very important in the 3D printing. So that's why even AICTE also, they are taking this subject, an emerging subject as a 3D printing and design, not only 3D printing. Without design, we can't do anything in the 3D printing. So majorly in the 3D printing, okay, we are this in the 3D printing, so many files are going to supporting nowadays. The earlierly only STL file is only most common full format. Earlierly only they are using STL file format. Okay, nowadays we are using the OBJ. Okay, nowadays also we are using the OBJ. Okay, most probably this STL is what STL is using for the normal printing purpose, or only one color printing purpose. The .obj we are using for the color 3D printing purpose. Even now we can use the VRML, AMF, 3MF, X3G. The I2 manufacturing file format, okay, this is AMF, even this is a 3D manufacturing file format. Okay, this is given by the ASTME. And these are Microsoft people, they are invented their own software or their own file format as a 3MF file format. Okay, in the future, you can see AMF and 3MF only. Because in the STL and OBJ, a lot of drawbacks are there. And we cannot we cannot add the tessellation information, and we cannot add the color information in the STL file. We cannot add the texture information. So many drawbacks are there, and so many errors also there when we are converting the surface data to the STL file. All those things, okay, we are going to minimizing, and we are getting the additional features when we are using the AMF and 3MF file formats. Now here, how we are going to develop a STL file? The STL file, maybe we can develop with using 3D CAD model data, and maybe we can use the CTR MRS scan data, and we can use the 3D object digital system. How we are going to develop a STL file with using the 3D CAD model? Okay, already you know, so many members nowadays, they are using the CAD softwares. Based on the CAD software, we are going to develop a STL file. Now you can see here, may I show them here? This tool, is it visible by PPT properly?
Yes, sir. Yes, sir.
Okay, thank you. Okay, here in the 3D CAD model, okay, nowadays so many softwares are available. Now you can see here. Okay, without the engineering background, you can make your model. Even nowadays, there's so many members, even non-mechanical people also, they are developing their own models with using the 3D printing software. Even architecture people, even interior design people, even film industry people also nowadays, they are using 3D printing technologies in their own field. Okay, without the engineering background, okay, you can develop your product with using the software, Tinkercad, SketchUp, 3D Builder, 3D Slash, all these things. So many softwares are available here. Even in the industry, in the film industry, people nowadays are using these softwares: Maya, ZBrush, Blender, Cinemax, 3ds Max. When especially the architecture people, they are using 3ds Max. Even if we are using the engineering people, we are using this AutoCAD, Fusion 360 already. You know, so many softwares nowadays we are using this one. Here, the almost all everywhere, okay, you have to develop the CAD model. That CAD model you have to convert the STL file that we require. Why we require the STL file? STL file is a standard file format in the 3D printing industry. How we are going to develop a STL file, okay, with using the 3D CAD model? Just I'm giving a small demo today. In this one, within 5 minutes I am going to finish, because already you so many people they know how to develop a CAD model, how to convert the STL file. But those who are new for this 3D printing technology, that people they can get some knowledge when I'm giving this presentation, when I'm giving this demonstration. Okay, this is the CURA software. Okay, we are using the CURA software in our university. The system is a little bit slow. I want to make a sphere. So first I'm taking sketcher. In the sketcher, I'm selecting one plane. I'm going to 2D view. First, I'm selecting the center line. Then after, I'm selecting a one off circle. Why? Because I'm going to do some revolve option in this CURA software. Okay, when I'm doing this revolve, okay, this off circle is rotating to the center axis with 360 degrees. Then we can make a sphere. And that's why I'm going to do the sketcher in this CURA software. Okay, here I made a off circle. Then I'm clicking here. Then I'm going for the revolve. So just I made a sphere here. So here I want. So now here I want to make a STL file here. This sphere. Just go for the file. Save it first. Save this file on desktop. Then go for the file. Save as. Here, when I'm going to save as, now you can see so many file formats are available. I require the STL file, the stereolithography STL file. Just I'm clicking the STL file. If you want, you can go for the OBJ. Okay, this is also supporting for the 3D printing. Even you can use the VRML. Already I showed in my PPT whatever the file formats are supporting for the 3D printing. And here, ASCII, snap, zip. Even AMF also we can use. Okay, these file formats we can use for the 3D printing. Okay, the generalized and popularized file format for the 3D printing is the STL file. Those stereolithography. Just I'm clicking here. Okay, now you can see here. I converted this sphere as the STL file. Now you can see the total surface is tested by the triangle. Okay, this is a triangle. The triangle, the total is tested on the surface. Now you can see, is it good? Is it good STL file? No, because now you can see here, there's some errors. Okay, it is not exactly curvature. Here some linear shapes are there. So I wanted to reduce these errors. Almost 70% of the people, those who don't know 3D printing, just they are converting the STL file, they are going to for manufacturing. But when we are going to convert the STL file, you have to take care about this accuracy. Okay, if you are getting the inaccuracy in your STL file, the same, okay, you are getting inaccuracy in your 3D printing model. So that's why when you are converting, you have to take care about this accuracy. You have to reduce as much as error in your STL file. Yes, I'm going to select STL file. Now go for the custom export. These options you have to use when you are going to convert the STL file. Now you can see here, okay, some options are available: chord height and angle and step size. Okay, this is a chord height. Okay, whatever the height is there for the triangle, that is I'm representing the chord height, and this is the angle. Okay, this is the chord angle here. And now I'm selecting as a 0. Here also I'm selecting a 0. It is not selecting the 0 actually. It is selecting the 0 into 10 to the power of minus 16 here. That value it is taking here. When I'm selecting here 0, it is not taking the 0. It is taking 0.034. Then once again I'm applying here. Then click here, OK. Now you can see how it is look like. Now we are getting the higher accurate part. So like that, you have to develop your CAD model. You have to develop your STL file when you are converting the STL file. Please take care when you are converting the STL file. Okay, you have to ensure it should be minimum chord height and chord angle. Okay, in the Clio, it is giving these options. When you are going for the CAD, yeah, they are giving the different options. If you are going for the SolidWorks, it is going the different options. But okay, your intention is you have to reduce the triangular height. Then automatically we can increasing the accuracy of the STL file. Okay, that is I'm going to give a conclusion. Even okay, just I wanted to save in the additive manufacturing file format. Now you can go This is the AMF file format. Just I'm clicking here AMF. Now you can see how it is going to convert here. Now you can see here. The triangle size is decreased. Okay, the number of triangles are decreased, but the accuracy also increased. Here they are using some test. Okay, these triangles, they are using adaptive triangulation method. They are used to convert the triangulation on the surface. Now you can see here where we require the curvature, and that it is taking the lesser chord height. Okay, where it is having the lesser higher height, the triangle height, then it is taking the higher height and higher chorded angle. That means wherever we require accuracy, there it is taking the so many number of triangles. Wherever we don't require accuracy, there it is taking a small number of triangles. Like that, here they are taking the it is taking the different triangulation method, okay, to convert the STL file when we are converting from the CAD model. This is called the adaptive triangulation method here. With using the adaptive triangulation method, they are going to develop a STL file. Here we can reduce the file size, we can increasing the accuracy. These issues automatically in the AMF file format, they are rectified. Okay, but in the STL file, you have to take care about yourself. But this AMF file automatically will be it can convert. Okay, this is about converting the CAD model to the STL file. Now, the second method, we are going to converting the STL file from the CT or MRI scan data. So what is the CT? What is the MRI? The CT is a computed tomography and MRI is a magnetic resonance imaging. Okay, nowadays, okay, these two techniques are very popular in the medical industry to extract the bony or to extract the tissues of the human. Not human, even nowadays the CT scans is using in the industry also. Okay, what they are doing here, first they are extracting the human tissues. Then these tissues they are converting as images. These images we are converting the STL file. How we are going to convert, how we are capturing the data, how we are taking the images data, how we are going to convert the STL file, that is we are going to learn in this session. In this one, the first one is the medical scanning devices is required. Okay, first we have to capture the data of the patient. Nowadays this CT is using in the medical as well as industry also. In the industrial, where we require the NDT test, non-destructive testing. Now, suppose this is a casting object. I want to check my blowholes on this casted object. How we are going to check, okay, with using this CT, the micro CT, they are taking the micro CT scanning of this object. Then they are checking on each and every layer. We can go up to 0.1 mm level. Okay, in the we can convert the 0.1 mm layers. In each layer, you can check, and you can check the small holes also, the blowholes, porosities. All you can find when we are taking the CT images with using the micro CT. Okay, that purpose nowadays this CT scanners is using in the industry. But I wanted to extract my my tissue. Okay, the bony tissues or soft tissues or hard tissues, anything. For that purpose nowadays we are in the CT scanner and MRI scanner here. And now you can see, okay, this is a scanner. And the scanner, okay, we are extracting the tissues. Now you can see this is a bone image, this is a lungs, this is a nose, okay, there is a heart in the inside, is a heart is there. All those things we can extract when we are using the different threshold values, when we are setting in the different threshold values in the medical CT scanning. Yeah. Any issues? Any problem? Can I continue now? Here, nowadays we are using this different medical scanning devices. Okay, that is a computed tomography, magnetic resonance imaging, ultrasound imaging, cone beam computed tomography, microcomputed tomography, positron emission tomography, single photon emission computed tomography, and tuned apertures computed tomography. And nowadays, so many medical scanning devices are available. In this one, CT or MRI are very popular. The computed tomography, the CT imaging is using to extract the hard tissues. Yeah, MRI scanning is using to extract the soft tissues. If it's using CT and MRI, we are going to extract the soft and hard tissues. Even we can use the ultrasound imaging to get the fetus information. Okay, for very soft tissue information we can get here. Cone beam computed tomography. Okay, these CBCT images, especially they are using in that in the dentist industry. The microcomputed tomography, where we require the micro level information. Under they are using the microcomputed tomography. Even our mechanical engineers nowadays they are using the microcomputed tomography to do for NDT test. Even positron, so many scanning techniques are available. The major principle of the scanning technique is, now you can see here, the patient is lying on the bed. On one side, the X-ray tube is giving the X-rays. The other side, the detector is detecting the X-ray beams. Here, this X-ray tube is rotating along this gantry here. This is called as a gantry. This is called a gantry. Along this gantry, the one side X-ray beam is there, and the side X-ray detector is there. When the X-ray beam is passing through the tissue, okay, the X-ray detector is detecting the tissues based on the energy loss. And now here you can see how it is rotating. Like whatever the nut and whatever the threads are there on the nut, like that. Okay, we are getting the information when this gantry is when this X-ray beam or X-ray tube is rotating in this gantry here. Here, this is the X-ray tube. The X-ray tube is giving the X-rays. The detector is detecting the X-ray beams when it is traveling, when it is rotating here. Okay, here on the bed, the patient is lying. So based on the energy level, we are observing the tissue. For here, we are using some back projection algorithms. So many algorithms we are using to get the images. Okay. Here, after in this one, here we are taking now here you can see here when this X-ray tube is there, the detector is detecting. Okay, the X-ray beams is passing through the tissue here. Here, based on the detected width, we are getting the thickness here. The minimum thickness of the X-ray, okay, this tissue is 0.624 mm. That much thickness we can get at one time here. So here, we are like that. Okay, when it is rotating, we are getting this much thickness, this much layers we are going to extract from the here to here. We require from this to this here. Okay, like that. That's why it is rotating along this X-ray, along this gantry on this bed. So after extracting the images, we are getting these images. Okay, after extracting the bony information, we are taking as a DICOM images. The DICOM means, okay, the DICOM full form is Digital Imaging and Communication in Medicine. Okay, with using these DICOM images, the doctors are detecting the problem, they identify the defect. Okay, they are going to do the surgical procedure based on these images. Where we having the problem, they are identifying, then they are going to do the surgery. But to make a medical models, to make an implant, to make a processes, we require all the images. This all the images you have to take and you have to merge. Then we can develop a CAD model. When we are developing this DICOM images, first it is taking the total full of the information. That is called the field of view. How much length you are going to extract, how much volume you are going to extract. Based on your gantry rotation, that is deciding the field of view here. That is a FOV. And then wherever the tissues are there, and that only the density is assigning, the remaining it is taking as a null. Okay, this here is a positive, here one, here is a null. Like that, here is some small back, or here we are capturing the data with using various back projection algorithms, various imaging algorithms. Here we are going to develop a 2.5D image. So what is a 2.5D image here? It is having the X and Y with uniform Z thickness. That is called the 2.5D. If the Z is varying, then we can say it is a 3D. But here the Z is uniform, so that's why we are considering as a 2.5D information here. So here, when I'm taking the diagram images, it is taking in a form of the voxels. What is a voxel? Okay, what is a pixel? Already you know. The pixel means it is a 2D images. It is we are extracting the X and Y information. Yeah, but when we are taking the voxel information, we're adding some thickness here. Along this X and Y, we're adding some Z. This voxel information we are extracting when we are taking the CT imaging or any scanning technique here. So okay, now these voxels we are arranging sequentially, and we are getting our required information like this one here. This is a principle of the CT images, and how we are going to develop the diagram images. These diagram images we are going to use to develop a CAD model, to develop a STL file, or to develop implants or medical CAD models here. Already you know. Okay, to develop a 3D printing models, we require the CT scan. Okay, CT or MRI data. That MRI data we are going to doing some processing with using the medical softwares, maybe the Mimix or 3D Doctor. These are the commercial softwares. And now we are going to use the 3D Slicer. That is the free open source software. And that we are going to develop a CAD model. That CAD model we are extracting and we are converting as a STL file. That STL file we are using for the manufacturing a 3D printed component. Then okay, the 3D printed component we are using for our application. So here in this one, to convert the CT image to the CAD model as well as STL file, we require some softwares. The medical softwares are required here. Nowadays, so many medical softwares are available in the market. There's a 3D Slicer, 3D Doctor within the medical design studio, Mimix, USA 3D, D2P, Cinema 4D, Mesh Mixer. Okay, so many different type of 3D medical softwares are available. In this one, 3D Slicer, it is an open source software. The Mimix is a very better and best, but it is a commercial software. We can get exact models, and here so many options are available in the Mimix software. Okay, now I'm going to give you a demonstration how we are going to convert the CT images to the STL file with using the 3D Slicer software here. Already I have forwarded the instructions to download the software as well as to do the practicing. Okay, I have forwarded the diagram image also. Okay, those who are interested, please join with me. Okay, how I'm doing here, you have to do in your computer, then it will be finished and you can get easily. So let's start the CAD modeling with using the CT images.
Yes, sir.
Okay, thank you. Please, all of you, open the 3D Slicer software, because okay, we are going to giving an online practice session in this session. So that's why okay, we have to follow. You have to follow with me. Then it is easy for me and you also to develop a CAD models, to develop a STL file with using the CT or MRI images. After opening here, you can see this is a 3D Slicer software window here. Here, in this one, okay, we can load the data. We can extract the diagram images and we can save. These are some icons. Here, in this 3D Slicer software, so many modules are there. You can see all the modules. Okay. For Bain, they are using different modules. To want the images, you can use. If you want to add the colors, you can use different volume. If you want to crop the volume, you can use the different module. Okay, here for the different application purpose, we are using the different modules in this software. These are the various modules you in this 3D Slicer software here. In our class, okay, we are going to use crop volume module and diagram module and editor module. only the volume rendering module. These 5 modules we are going to use to develop a diagram. First, we are opening the diagram images. Then we are extracting the board from the diagram images. Then we are cropping whatever the images required, that images we are cropping. Then we are converting as a CAD model with applying various threshold values. Then we are converting as a STL file. That is, we are going to do in this practice session. It is, but here so many modules are available. Based upon our requirement, we are using various modules here. Here, if you want, you can, okay, these modules, okay, whatever the important modules are there, that you can see here. There's a volume module, and there's a models, and there's a transfer, there's an editor module. Okay, so different modules you can see on the bar, on the toolbar here. Okay, if you want, you can directly capture, and if you want, you can take the screenshot also. Directly, you can capture here. And do, okay, without the key button, you can capture from here. And if you want, you can extend some modules. And nowadays, this 3D slicer, okay, they are giving different modules. This modules directly you can extract with using this button. If you want, you can write your own module. Okay, you can with the Python software, and you can set up the, you can directly access from that Python programming to this 3D slicer. That facility is also available in this software. So that's why this is very, very popular. This is an open source software. Anybody can do. Okay, anything you can do here. If you want, you can edit. If you want, you can add your own features. If you want, you can write your own program. That also possibility is available in this 3D slicer software. So that, okay, here this is the okay, these are different the different views you can see when we are importing the diagram images. This is the 3D window here, where you can see the 3D dimensional model here. First, I'm going to do the load diagram data. Please, all of you, click the load diagram data. When you are clicking the load diagram data, okay, this diagram browser will be appear. Then you can import the images. Import your diagram images. Here, diagram is a standard file format in the medical community. Here, in the 3D printing community, whatever the STL file is a standard file format. Similarly, the diagram is a neutral file format for the medical community. So that's why, okay, you can take CT image, you can take the MRI image, you can use the CBCT, you can use any type of medical scanner. Okay, they are saving as a diagram file format. Because even nowadays, the radiologists and doctors are having their own softwares to open the diagram image and to extract something. Even nowadays, they are also doing some virtual surgery in their own softwares. So that's why this medical community, they are using the diagram is a standard file format nowadays. Then you can import, okay, where the diagram is all there, okay, you have to go for that file, that diagram. Okay, I'm going to extract the diagram images here. Just click the diagram images and then click import. And now the diagram images are importing in this 3D slicer software. The 3%, 30%, 40%, 50%, 60% is over, 70, 80, 90. So now you can see how this much time taking here. Now you can see here one new patient file is there. We are going to do one study. Here one new series is there. In this one, totally 400 new instances are there. That means here we are having the 400 images. If you want, you can see here. This is a diagram images. Now you can see how many images are there here. 400 items are there. That means 400 images are there. These all the images we are going to extract and we are going to import in this 3D slicer software to develop a CAD model. Okay, once you are importing is over, then choose this one, and you have to. Now you can see here the study. Here there's a patient birth. Okay, this is a birth date, and this is a number of series. Now you can see 400 number of columns are there. That means number of DICO images. These are CT data. Okay, you can use the MI data, you can use the different data, also you can extract, but we require the DICOM file format. Here, this is totally, this file is it in the form in the voxels. Already I'm given information, the CT or MI or any medical data, it is consisting the voxel data, not your pixel data. And here now you can see the file, okay, the size is a 512 by 512 mm. Now you can see here, is a 1 mm voxel. So the total 400 images are there. Total 400 images are there. Each image consisting of the 512 by 512 matrix size. Already you know what is a matrix size. Okay, that means pixel size. Okay, 512 pixels in the row and 512 pixels in the column. Like that, totally 512 matrix is there. The each matrix, it is having the 1 mm voxel. That means 1 mm by 1 mm by 1 mm. The 1 mm cube voxel is there. Based on this, they are developed the DICO images. That is telling about this information. Then just click the load. Now the DICO image is going to load in here. Have you got this one? This window? If suppose you're having any doubt, any query, you can raise your query. All of you got this one? Those who are doing the practicing?
Yes, sir.
Okay, thank you. Okay. Here now, okay, these are the DICO images. Okay, these are the different views. Okay, here in our mechanical community, we are having the top view, front view, side view. Similarly, here also, they are having their own views. Okay, now you can see here that views, okay, they are having the axial view, sagittal view, and coronal view. They are calling the different views in the medical community. And now you can see here, these are the legs. Okay, okay, I extracted this hip and with the legs, this totally body, I extracted the DICO images. The DICO images imported in this 3D slicer. And now here, okay, in the medical community, when we are looking from the top to bottom, okay, that is they are calling as a anterior to superior view, superior to anterior, from top to bottom. That is called the superior to anterior. When I am looking from the front to back, okay, that is representing as a anterior to posterior. So when they are looking from the side, okay, side view, when we are calling as a side view, okay, in our mechanical community, in the medical community, okay, in the mechanical community, they are calling as a proximal to the distal. That is called the left side to the right side view. That you can see here. Okay, this is the front view. Okay, when we are looking here, this is a front view. That is called the anterior to posterior. Whatever. Okay. Here now you can see. Okay, this is a side view. This is called the proximal to distal. Okay, this is a top to bottom. Okay, this is called the superior to interior view here. Like that, okay, we are going to extract the different views in this software. Now I'm going to first going for the volume rendering. Just I'm clicking the volume rendering module here. Now you can see here. Just I'm going to click the volume because I require this volume. Okay, this is a 1 mm boxes, whatever the information is required that I wanted to show, I wanted to see. So that's why I'm clicking the volume. Then I'm going to do some cropping. So that's why I'm enabling the cropping. So whatever the region of interest, ROI, okay, that I'm going to see. That's why I'm going to click ROI, region of interest. Here in this box, whatever the region is there, whatever the tissue is there, that you can see, that you can extract. So that's why, okay, we are taking as a reason ROI here. Then select the, okay, here the two in the different 2D view, you are going to extract, you are going to see. I want to see the 3D view. Just you have to click here, center the 3D view on the same. So now you can see here, this is the tissue. Okay, this is the tissue. Now you can see this is the totally what we are extracting in the CT image, that tissues you can see here. So from this tissue, okay, this is consisting of the bone, and this is consisting of the hard tissues and soft tissues or muscles, all those things. From this, I require the bony part. So that's why I'm going to choose here. Go for the present, go for the present. Here you can see different options are available. CT bone, and if you want CT cardiac, if you want to extract the cardiac, okay, if you are going to the angiography, you have to click here. If you want to see, okay, if you want the cardiac too, okay, you can extract here. Please, okay, hold on 1 minute. I'm having one call. Please don't mind. Okay, sorry. Here, okay, now, okay, I'm selecting the, okay, if you want the CT chest, you can choose this one. But whatever the tissue is required, okay, based on the tissue, you have to choose the different values, different bony parts here. Okay. Next, if you want the coronary, you can choose this coronary, and if you wanted to choose the only fatty is required, that you can do, and okay, you can select. And okay, if you want only CT soft, okay, soft tissue, you can choose. If you want only the nerves, that also you can choose. If you want the this chest part, that means the lungs, whatever the area information is required in the lungs, that also you can extract. Here, based on your information, okay, if you want to extract the brain information, you can extract. Okay, whatever the region of interest, okay, whatever the CT image are there, okay, based on that, you have to choose the various options here. Here, I require the CT bone because I require the bone information. Okay, here. So that's why I'm selecting the bone. Now you can see when I'm clicking the CT bone, all the tissues are went out. All the tissues are vanished here. Now you can see here. Okay, this is my CT bone here. Okay, here, okay, you can see the bone information you can see here in this one. So now, okay, here, but the bone is there, you can see, but it is not good. Okay, here is something soft tissue also attached here. So I wanted to adjust some threshold values here. Thresholding here, we are going to assign a density values, what we are calling as a density in our mechanical terminology. Here they are using the thresholding. Based on the threshold value, they are going to extract their own region of interest. Okay, they are going to extract their individual parts. So that's why I'm going to apply the various threshold values with applying this shift here. Now you can see. Okay, this is totally fast when I'm extracting. Okay, this you can see here. This is the air, this is a soft tissue, this is a hard tissue, all you can see here. When I'm going to apply the higher density here, now you can see the almost all air is going to collapse now here. Now you can see here, this is totally soft tissue. When we are lying on the bed, on the CT scan bed, now you can see these are the tissue, this is skin. Okay. Okay, this is my CT bed. You can see here. Okay, suppose, okay, when we are moving during the CT scanning, like this address is coming here, because when we are moving, automatically the bone information also going to move when we are extracting the CT images. So that's why they are insisting to us, you have don't don't move your parts like that. So this is a one defect here. So I want the CT information. I don't want this soft tissue. I don't want these muscles. So you can see this is soft tissues. This is a knee. Now slowly I'm adjusting my threshold values here. Now you can see here. So almost all. Now you can see here in this one, the totally the soft tissues also vanish here. Only muscles with bones you can see here. Then once again I'm adjusting here. I require only bone information here. I don't require these muscles. So that's why I'm adjusting here. I'm flexing here. So, okay, now here, okay. I'm adjusting more. Now you can see the bone also going to vanish here. So I require the bone. So just you have to adjust here. Okay, just I require the bone information. Please all of you adjust here. Like that, okay, you have to adjust here. Now you can see here, from the totally soft, okay, from the totally tissue, I extracted only bony part here. Okay, this is a left leg, this is a right leg, okay, this is a pelvic and hip, all this information you can see here. So I require only pelvic region. This region is only required. I don't require this bony part, because here, okay, they wanted to see here the way of this bone at this region and at this region. So they don't require this bone. But actually, when they are doing the CT scanning, they are taken from here to here, from the knee to this hip. So that's why they are not concentrated here. So I require this only this pelvic region here. How I'm going to extract this region only. Now here, go for crop. Okay, now I'm going to do the cropping, because I require only this information only. I don't require this information. So I'm going to do the cropping of the images, entire the 400 images. I want to remove this region. I'm going to extract only this region here. So for that, I'm going to do some crop value. Now here converts and go for the crop value here. Just click here, converts and crop value. Here now here this is the crop, okay, the cropped box here where we required, okay, and that only you can use here. So now you can see here, when I'm going to move here, automatically our okay, different layers you can see here. This layer count also you can see here from here. In the different areas, in the different layers, you have to identify where we require the images, where we require the tissue. That images you have to keep, remaining images you have to remove. Then we can extract only this pelvic region here. So here, in this also, okay, this is the different view. Here also, this is a different view. Now I'm going to extract. When I'm clicking here, okay, just I'm adjusting these boxes, just you have to press it and drag it here. Now you can see. Okay, when I'm going to doing here, automatically you can see in the 3-dimensional. Okay, now you can see how it is there. So I don't require here also. So I want to change. Okay, here is I'm pressing here, then I'm extracting here. I don't require here this image, this image also don't require. But here also something is cutting. So you have to see on the 3-dimensional image. So okay, up to this one is over. Okay, this is required. Okay, good. Okay, now here along the length is over. Just along the width I want to adjust here. Then I'm choosing this one here. So when I'm adjusting here, automatically it's going to back here. So something is going to cropping. So that's why I'm taking the different region here. In the different view, I'm going to do extracting like this one here. I don't require here this bony part, this one. I require only this pelvic. Some of the pelvic is going to removing. So that's why I'm keeping here. Next here also. I don't require this one. When I'm going here, this is also something is going to damage. So that's why I'm choosing this also. Now you have to adjust this length also. You have to press it and drag it here. Now you can see here, from this total tissue, we are extracted here what we require here. Okay, I require only this region. So that's why remaining totally images I'm going to removing with using the crop volume option here. So first you have to choose this volume. Then go for here crop volume. If you want, you can do the cross scaling. If you want, you can apply the different B-spline method and base linear method, all those things here. Already you know the nearest neighbor method to interpolate the images. Interpolation techniques already you know. Okay, based on the interpolation technique, we are going to extract the 3D CAD model here. So from we are taking the curves to surface to volume. Like that, we are going to develop our CAD model. Same technique they are using in this 3D size software also. Okay, here among these four, okay, you can use the nearest neighbor method, or Windows scientific method, and linear method, and B-spline method. Among this one, the B-spline method is we are getting the high quality, but it is taking some time. But I require the high quality, so that's why I'm choosing the B-spline method to interpolate the images. Here we are having the 400 images. Each image is having the various cross section. Okay, to extract the cross section of the each individual image, and this all images we are going to match, then we are going to develop our CAD model. So that purpose we are using the B-spline model to extract the image in each level. So then click apply here. So it is taking some time because it is going to calculate in the 400 images. In each images, it is going to develop a individual outer boundaries. Now, after computing, now you can see how it is going to look like. The total image is going to deleting whatever the region is required. That region only you can see. Is it clear still now? Did you follow with me?
Yes, sir.
Thank you. Thanks for your response. So here it is taking some time because the 400 images, it is going to extracting the data. So please hold on 2 minutes time. Okay, for this medical software, we require the high-end software under this good compatible computers are required to extract this type of information. It's going on. So it is not responding. So it's taking 2-3 minutes to extract this data. Oh. Oh. How many members are doing? Please write in something in the chat box, those who are following with me. Are you extracted the images? Now you can see here. The total images are capped and only this image only you can see here. So this is a crop volume is finished here. Then once again, I'm going for the volume rendering module, and I'm removing this enable, and I'm going to remove this display ROI. Okay, this because of this is the normal soft tissue, normal the initial tissues I'm going to removing. Okay, I wanted to work the new tissues, so that's why the previous tissues and previous models I'm going to remove it. So that's why I'm enable these options here. Then go for the editor. The next option is editor. Okay, now the crop volume is over, and the crop in the cropping volume, the cropping module, you crop out the images. That cropped images you have to add, then you can get the 3D model. So for that, we are going for the editor here. Legacy, then editor module. In the editor module, we are going to edit, and then we are going to stitch together all the images. Then go for the editor. So then here you can see create a merge label map or segment for selected master volume, reassembled to 1 mm voxel crop. So here now once again we are going to reassembling of this 1 mm voxels in all the images. So that we are going to do here with using this editor module. Just I'm going to click OK. Then automatically when I'm clicking here, automatically some voxel cube algorithm is going to work here. Now you can see, okay, this is the now here. Now from here, we require the bone information. So here, whatever the information is required, once again, you have to choose, I want to require the bone. Just click the bone. Okay. Now here also, once again, you have to choose the threshold value. When we are choosing the threshold value, that region only we can extract. So go for the threshold effect here. Here, different options are available. I will tell you. Just I will tell you here threshold value. Just click the threshold effect. When I'm clicking the threshold effect, now you can see here. Now you can see the totally bone is extracted. The totally bone is you can see the totally values are assigned on the entire region. But you have to choose only the particular bone. So once again, you are going to do here. Now you can see the threshold range -453 to 1336. That means from this density to this density, you can extract that region of interest. So that's why okay, I wanted only bone information. Okay, that the threshold I'm going to select. If you know the threshold value directly, you can type it and you can set it. But okay, almost okay now okay, the different patient having their own density values. Okay, that these are very difficult to find the threshold value for that particular patient. So we have to adjust here. Now I'm going to use this cursor. Just I'm adjusting here. Now you can see here. When I'm clicking here, the totally bone is going to removing here. Just I'm adjusting here. Now you can see the bone is assigning with using this density. Here high density bones are this. That's why it is taking initially this value, this density. So just I'm going to click here. Now it's good. Yeah, now it's good. Okay, when I'm coming here, okay, here you can see the unwanted tissues also coming. So that's why I'm adjusting this side here. Based on that, you have to extract. Now, if you want, you can add some layers. If you want, you can remove this one. Okay, what we are doing, our paint in paint, whatever the options is available, like that you can do it. If you want, you can paint. You can extract the information. You can write something. If you want, you can draw something here, like that you can do here. Like that, if you want, what you want, you can do it here. So I'm going to do the shouldering. So once again, like that, different options are available. Because of this time constraint, I'm not giving so much information. Just whatever we require that I'm going to give here. Okay, once bone is assigned here, the density is assigned in this bone, then go for the apply. This density, this threshold value, we are going to apply here. Okay, once is applied, okay, density is assigned. Now go for the label effect, the make model effect here. The make model effect means the total density, based on the density, we are going to develop a model. So that's why I'm going to make a model effect here. Make a model effect, click here, then apply here. So it is taking to develop a model. It is taking some 2-3 minutes. Just hold on. Now you can see, this is our required model here. Now here, the total from the total board, I extracted only this model, only this one here. So here in the editor, you can remove these tissues in each. You have to go in each and every layer, and you have to remove this one and remove this one. Like that, you have to do here. It is take some time to. If you want, you can extract the poly data. If you want, you can use the OBJ file format. STL and OBJ both files we can use for the 3D printing purpose. So I require the STL file. Then where you have to save the STL file, that also you have to choose. So I'm going to save on my desktop. Then save it, this bone STL file on my desktop. Click here. I'm using various softwares, so that's why my system is hanging here. Okay. Now you can see the bone. Now you can see here the properties. Just check the properties here. Now here, just now I saved this one, the STL file here. Okay, this STL file I want to open in my software here, in my CURA software. So directly, I'm opening my CURA software here. Already you know, okay, we are downloading the CURA software. Okay, how we are going to convert the STL file to the size information that is I'm going to present in my session here. Just first go for the open the STL file, load. So I'm going to remove delete this one because it is taking some data. So I think all of you got it, how to convert the document to STL file. Is it okay for you? If you are having any doubts, please raise your question. Otherwise, I will go for the CURA software. Do you have any doubts still now? Is it clear about the 3D slicer? Please respond something. Just started something.
Clear, probably. That's why.
Okay. Okay. Thank you. Thank you for your response. Thank you, Rajana. Yeah, just I'm closing this software because it's taking so much data. So here, that data, okay, that one I'm going to extracting here in this one. This is already make a CURA software, already you know. Yeah, this is my working this build platform. Here, this the CURA software is an open source software. Okay, nowadays, so many 3D printers are using this CURA software. And this is developed by the Ultimaker people. This is a STL file. I want to extract this STL file. Suppose I want to move this STL file. You can move just okay this with applying this one. If one okay, this is the x-axis. Okay, this is my y-axis. This is my z-axis. Okay, where we are going to move like that, you have to choose this one. Okay, when it is fitting in this build platform, then it will be show yellow color. Now you can see now this spot is fitted exactly here. Okay. If you want, okay, you can set the dimensions also, where we have to keep this part with using this dimension. You can adjust here, and if you want the rotation, you can do the rotation also with using this icon. If you want to use some scaling, that also you can do it here, scale. So I will show you how to rotate this part. Okay, this is the x-axis, this is the y-axis, this is the z-axis. Here now I want to rotate here along this axis. Now you can see here how it's going to rotate 45 degrees, 60 degrees like that. I can rotate here with you when I'm pressing here, then I'm rotating here. Next, here I can rotate in the y-axis as well as in the z-axis like this. Okay, here different parts having their own orientation. So our orientation means where we are going to set up on the build platform. This STL file that is representing as a orientation based upon our convenience and based upon the material requirement, based on the build time, and all this parameters is effects on the part orientation. So just I'm clicking here. I'm keeping on my build platform, this one. Now, okay, if you want, you can scale. So how much dimension is required, that also you can do it. Okay, that is about this. Okay, here, this is if you want, you can move. If you want, you can do the scaling. So scaling means, suppose I want to increase the size. Suppose I instead of 100%, I'm going to do 200%. Now you can see like that. We can increase or decreasing based upon your requirement. Suppose you did this model in the STL for you are taken dimensions during the design. You want to do inches. So directly you can convert with using the scaling options. If you want, you can do the snap scaling also. Only in the one axis, you can do the scaling. Only in the x-axis, I want to compress. That also possible. So not uniform. Just select here. Like that, you can see here in the x-axis only it is expanded. In the y and z is same. Like that, in the individually you can extract the scaling. When we are going to considering the shrinkage factors in the plastic-based machines and in the machine-based machines, these scaling factors are required to get the accurate parts. So that's why you have to do in the own scaling factors in each axis. That is required here. On that case, we are using this one. So remaining one, okay, you can see here, okay, so many options are available here. Okay, whatever the machines are required, that machines you can connect with using this one, add your printer. Suppose I'm using the Ultimaker S5, you can use this printer. Otherwise, you can choose the different printers. And whatever the material is required, that also you can choose. And here, now you can do various custom products here. So whatever the layer thickness is required. Okay, I'm telling to you, in this model, I'm going to do the slicing. What is the slicing? Here, along this z-axis, we are going to split the layers. That is called the slicing here. Because we require the slice information for the additive manufacturing purpose. So that's why we are going to the slicing. That slicing data we are going to send to the machine. The machine is extracting each slice. Based on the slice, okay, whether the nozzle is rotating or the laser is rotating or the laser is tracing the path. Okay, here for this we require the slice information. So whatever the slice thickness is required, that you can define here. So 0.062 up to 0.2 mm. This much layer thickness you can give based upon your application. I require higher accuracy, just choose the 0.06 mm. I require only rough object. I require only object, they don't require the accuracy. Then choose the 0.2 mm. Like that, for our application, we are choosing the various layer thicknesses. And wall thickness. Okay, wall thickness means when we are going to do the object, first it is taking the contour. The mold is tracing, the nozzle is tracing the contour. That means on that contour only the metal will be purged. Then after filling the inside. Like that, it is going on in the I2 manufacturing process. Here, whatever the wall thickness is required, for that shell, you can decide here how many wall numbers is required, and what is the bottom layer thickness, what is the top, okay, top layer thickness, how many layers are required for the base plate. Now you can see the number of top layers, that also you can assign here, and bottom layer thickness, and how many bottom layers are required. Here, what is the infill percentage? The infill density means how much density of the component is required. Is it required 100% density? Is it required 15% density? That you have to decide yourself. When the density is increasing, automatically material also increasing, but we can get the higher strength. Even infill pattern. Okay, just now I informed you first in the 3D printing process, it is going to the contour information. It is going to add the material on the contour, then filling the material inside. When the material is filling the inside, it is taking different contours, infill patterns. That patterns you can see the grid lines, all those things here. The cubic, hexagon, okay, different type of patterns you can choose. Even okay, if you want, okay, you choose the different material. Based on the material, you have to set up the temperature. Suppose PLA metal is there, it is enough up to 200 degrees. Suppose you are taking the ABS plastic, you have to use the 230 degrees temperature. Based upon your material, you have to adjust the temperature and how much speed is required for the print. If you require the higher speed, okay, if you require the old prototype, you can choose the higher speed. If you require the functional part, you have to choose the lesser speed. Like that, you have to decide. All these parameters you have to set up in this 3D Slicer software, in the CURA software. Even travel speed, in the whatever the cooling fans are, all these things you can do. In this one, the supports also you can add here. What is the supports? Wherever the overhanging objects are there, and that we require some supports. Without supports, we can't manufacture. So that's purpose we are going to add the generate supports. If you don't want the supports, you can remove the support also. That also option also available here. So I require the supports. Just I'm clicking the supports here. Yeah, okay, travel supports. The supports also, you can see touch. Okay, here touchable support are everywhere support. When I require the minimum supports, you can choose the touching build-up plate. Okay, I require the higher supports. Okay, you choose the everywhere. Like that, you have to choose the supports options here. In the build platform, how it is going to add. It is a beam or skirt and raft and one. Here, various options are available in the CURA. Based upon your requirement, you have to choose here. And sometimes, okay, we are using the dual extruder. Majorly, this Ultimaker CURA software is supports the FDM-based machines, fused deposition molding machines. So that, okay, here in the fused deposition molding, we are using the extruder. Through the extruder, the material will be purged. Sometimes we are using the single nozzle, sometimes we are using the dual nozzle. Here, if you require the two nozzles, you have to choose the dual extruder also, based upon your printer. Here, these options you have to choose. Then you can do the slicing. Okay, here, just I'm applying here. Okay, now here. This is my parameters. I'm choosing 0.1 mm. So I'm using the 0.3 mm, suppose here. Like that, what you are required, you can choose. Next, here, I'm choosing the support also. These parameters are chosen. Then I'm going to do the slicing here. Just click the slice. First, you have to adjust the model in the build platform. If you want, you can rotate. If you want, move. If you want, do the scaling with using these options. Then add all the parameters here, whatever the parameters required. So that's why in the first slide, I shown to you that we require the softwares up to this stage, up to this one, like the CAD model, STL file transfer to the machine setup. And now we are giving the machine parameters in this CURA software here. Then you click the slice. Now it is doing the processing here. Now you can see here, it's doing some processing here. Now you can see, to make this model, we require the 11 hours 1 minute and 30. And we require 131 grams and 60.53 meters of the wire. This much wire is required, this much metal is required, this much time is taking to print the model here. I want to see the preview. I want to look the layers and I want to look the support structures here. So go for the preview. Now it's going to preview. Now you can see here, these are the total layers. 480 layers is taken along the Z axis here. So just now I informed to you, okay, that when we are converting the slicing, okay, it is going to splitting the layers in the Z axis. Wherever the hollow portions are there here, here the hollow portions are there. So that's why the supports are developed here. This one, this one, this one. These are the supports. Okay, because of the support only, we can print the model. We can print this hollow portions. So that's why we are using these supports here. So if you want, you can see the layers in each and every way, in each and every layer. There's a first layer, second layer, third layer, like that. We can see here. Different layers. You can see the layer information, contour information. Now you can see this is the hollow portions. Okay, based on the density we are setting this hollow portions here, and based on the infill percentage we are choosing the density, as well as based on the infill patterns we are choosing these patterns to fill the material. First it is taking the contours, then filling the inside the material. Okay, like that, okay, layer by layer it is going to make a layers. Lastly we are getting our required object after finishing all the layers. Like that, we are going to extract, we are going to build a model in this 3D printing software. Here, okay, first we are going to develop the STL file. That STL file you have to open in the CURA. Then you have to set, okay, you have to adjust the model on the build platform. Then you have to set up some parameters, whatever the parameters required. That parameters you have to adjust in this one. Then go for the slicing. And now here you have to choose the various orientation based on the time and based on the material. Suppose different material having different objects having their own orientation to reduce the material, to reduce the time. So you have to play something. You have to play. You have to change the different orientation, and you have to optimize the material. You have to optimize the time to utilize your printer, to utilize the effectively for your printer. So like that, you have to change the different orientation and different fill percentage and infill percentage. You can choose the different patterns, infill patterns, and you have to choose the various support structures also here. Like, okay, all these options you can see here. This one. Okay, this is about Ultimate CURA. Here, okay, very good. I'm not telling about this 3D model of how to. Okay, the third method is we are converting the STL file from the from the 3D scanner. Okay, tomorrow, day after tomorrow, you're having the demo. I'm not showing anything. Just here, I want to tell you one information for you. Is it clear about this CURA software? Do you have any doubts in this one? Here, from the CAD model and from the STL file reverse engineering, we are going to convert the STL file. But this STL file, directly we cannot use the AIM softwares, the 3D printing softwares, what we are using the CURA software. Here, intermediately, we require some STL treatment softwares. Okay, might be you studied, okay, when we are during the MTech or during the BTech, okay, in the CURA book, there's some STL file errors also you are studied, and might be in 6th chapter. Okay, that gaps, missing faces, overlapping faces, degenerate faces, and non-manifold problems. All these problems you might be or see. When we are doing this medical CAD modeling, okay, when we are doing some architectural model, these problems will be arise. When we are using normally CAD model, these problems you can't see in any way, the STL problems, because the CAD model, it is following exact rules. But when we are doing the medical model, when we are doing some architectural model, they are not following any rules. The total data is different. Now you've seen where the medical data is taken from the voxel data. We are not taking any surface data. We are not taking any B-spines. We are not taking any nubs. They are taking the different data. So when we are converting this CAD to STL file, some problems will be arise. Not only in the medical data, if suppose you are taking from architectural data also, some problems you can see here. So I'm giving a small example. So just recently, we deal one problem. Okay, we are deal one project from the architecture department. Suppose you can see here, this ultimate CURA. So I think you are clear. So I'm removing this one, all these things. So here, so I'm taking one project actually here. The one they are developing one STL file. Here they are developing one hospital with using the architecture softwares. It is a 3D Max software. Now you can see when I'm opening this STL file, now you can see you can't get any data. You can see, are you seeing anything here? Nothing. That now you can see when it is telling models errors. Your model is not manifold. The highest area indicates either missing or exterior surfaces. That is indicating this is a problem. This is errors. Okay, this is manifold. One problem. Okay, those who are studying the STL file errors, okay, that people you might be Okay, I'm not explaining what is a manifold. All these things. It's taking some time. Here, this manifold, one problem is there because of this manifold, it is not attaching properly triangles. So that's why these problems are arised here. So here, okay, now I'm opening this same STL file in another software. Here, one software is there. Okay, we are using some Flashforge 3D printers in our university. Okay, I'm opening this STL file in my Flash 3D printer software. And now, when I'm opening in the CURA, I'm not getting any information. Just I'm looking, okay, it is some building is there, some model is there, but it's totally collapsed. So now I'm opening in my Flash print software. This is also one type of 3D printing, 3D slicing software. Here, what we did in the CURA, same thing you can do in this software also. Just loading the component, just wait 2 minutes. Okay, same order. I'm opening some STL file. Hospital. Now it is showing some warning. Now you can see, find some errors with this model. Do you want to delete it? If I'm deleting, now you can see the total model is collapsed here. That means some errors are there here. Suppose just I'm loading same file, because those who are working with the medical community, those who are working and another mechanical community, that people should know, should learn about these concepts. Okay, even engineering components are very good. We are following so many rules. We are following so many algorithms to develop the CAD models. But the medical community, the remaining people, they don't want about this CAD modeling techniques. Just they are looking only for the visualization purpose. But when we are converting the STL file, so many problems are arising. So now you can say find some errors with the models. Do you want to delete it? No, just I want to see some errors here. This model is off the platform. Do you want to put on the platform? Yes, I'm putting on the platform. Now you can see, okay, here something, it is bigger. So what I'm doing here, I'm going to do some scaling here. This component, I'm doing the scaling. So I'm doing some 80%. So no, sorry, it is meant the 800%, 80%. Now it is also big. So I want to show the model. So that's why I'm doing some scaling. But when we are doing the component, okay, just I extracted, I remove this component, then I manufacture this component. Now you can see here, this is a very good model. Now you can see now, okay, this is very good model. It is a multi-specialty hospital. Okay, now you can see this is a very good fine pillars. All those things you can see, very good model. Okay, the first floor. Okay, and when you're seeing here, you can see how they are doing. They are dealing very specifically. Now you can see, okay, how the interior is there. Yeah. Okay, you might be able to observe the roundness, round here. And okay, they are put it properly, these pillars, all those things. Now here, that again. Actually, what they are doing, okay, there's already some libraries are there. They are taking and they are only stitching here. It's just they are bothering about the shape, but they are don't bothering about the stitching. So because of this stitching, okay, we are getting so much errors when we are converting the STL file. So that's why we are unable to print the model. So once again, all these files we are stitched together, and then we are we are repair the STL file, then we are printed the model for this hospital. So just okay, I want to see you, I want to show you. Here now you can see when I'm opening, actually here roof is there. The roof is collapsed because the roof is not fixed properly here. When they are doing the CAD modeling, actually they are using the different softwares. They don't bother about the stitching. Okay, suppose when I'm doing some assembly, okay, we are following the full constraint model. If it is not full constraint, we are doing some another option. We are doing the full constraint, but they don't bother about these things. Just directly they are taking, they are keeping on the top. So, but okay, we require the constraints, then we can convert the good STL file. So all these issues we are going to resolve when we are using the AMF file format, additive manufacturing file format. And now, okay, I'm doing for the scaling here. So it is bigger, so that's why I'm unable to do here. Once then I'm going to scale. Once again, it was bigger. Now I'm going to print the model here. Here also so many options are available. Okay, what you are seeing in your CURA software, like that we can add the layer thickness, okay, shells, different type of shells. What is the infill percentage? What is the infill pattern? What is the speed? What is the temperature? All those things you can set up here. Okay, this is a machine setup. You can see any 3D slices or any 3D printing software, the options are almost all same. What we are using the CAD software in the CURA and the SolidWorks. Similarly, here so many softwares available in 3D printing. Now I'm going to print. Just click OK. Then I'm going to slicing now. You can see after slicing how it is going on here. Then it is going to slicing. It's taking some time. Just now you can see. After slicing, now you can see here, the totally part is collapsed. Now, actually, in the previously, the round shape is there. Now there is no round shape. Okay, now here also there is collapsed. Here also collapsed. Okay, all this here also collapsed. Why it is collapsed? Because there is no interconnectivity. Okay, because of this manifold problems, gaps and missing faces and degenerate faces. Okay, all these things we are going to stitch together and we are adding together. Then we can convert the good STL file. Okay, we are going to do some repair. Okay, that okay, I'm telling to you some STL treatment software is also required before going to the 3D printing slicing software. So first you have to develop the STL file, that whatever the errors are there, that you have to do. That's why we have studied the STL file errors in our curriculum. I think might be you also studied. And then you are going for the slicing. Okay, these up to now we require the software. Then this software, okay, then that models just we are going to simply converting the slice information, we are sending to the machine automatically will print the model. But up to now, almost 70% of the process, you have to work on the softwares. Without the softwares, without the files, you can't do anything in the 3D printing. Even design for additive manufacturing, that is a new concept. You have to do design according to the additive manufacturing to reduce the weight, and to increasing the quality, to reduce the cost, to increasing the strength. Like this, okay, we are going to do so much design for additive manufacturing techniques we are using. And that one of the technique is the topology optimization that you might be learn in the future, in the previous class, in the previous day. So okay, this is about the softwares, AM softwares. Okay, now you learn about the CT and MRS scan data to the STL file, from STL to the AM software that you will learn. That is, I'm giving the demonstration to you. Okay, whatever the information is required, CAD to the STL file, from STL file treatment, that also I'm given a small information to you. If you are having any doubts, we can raise. I'm ready to give answers for your questions. I think last 10 minutes is there. If you want anything, you can ask. If you are lagging to do some software, you can ask. Those who are did, okay, you can do one assignment. That is, I have forwarded to you. The 3D slicing practice CURA assignment here. The CURA assignment, okay, here, oh, this is the 3D printer is there now. In this one, you have to extract the different orientations, and you have to identify the time and material. So from that, which one is good, you have to give your one conclusion. A small assignment we are prepared for you. If you are having time, you can do, you can submit to the Shivaramakrishna sir. Okay, this CURA assignment. Okay, we have to, okay, you have to adjust the x-axis, different angle, x-axis 0, 45, 90. Similar y 0, 45, 90, the z 0, 45, 90. You have to adjust the model. Okay, that already I have shared the part with you. You are having the STL file. The STL file. There's a bigger one. Go for the scaling. Yeah, uniform scaling. Just 10 I'm doing here. So this is, I want the uniform scaling. Sorry. STL file, open it and do the scaling. Then move here. It is not showing yellow color, means it is having some more dimensions. It is going to outside. So I have to extract now. It is good. Now you have to rotate this one. It's using rotate button. Now here this is a 0. Suppose I am taking this x-axis. Okay, now this x 0 degrees is there. Now x 30. Suppose I'm doing here. Now, just you have set up here. Just calculate the time and material. Similarly, 60 degrees and 90 degrees. Like that, you have to change your various orientation in the x and y and z axis and prepare this assignment and send to the SAR. Okay, this is about your CURA assignment. If you are having any problems, any questions, if you are not unable to follow with me, just you can raise your question. Do you have any problem?
Thank you, sir, for the detailed and step-by-step explanation of 3D Slicer and CURA software, sir.
Okay, thank you, madam.
I request the participants to interact with Chari, sir, if you have any doubts. And I think this is the only session where we got assignments, sir.
Okay. Actually, Sharvara sir insisted to me to do some assignments like that.
Yes, sir.
So
Yes,
that's
sir.
why I prepared. Actually, I have shared the practice session step by step also. Yeah, without me, you can do yourself.
Okay.
Like that, I prepared. I have shared to the participants also. Might be the participants received the practice session instructions.
Yes, sir. All the instructions are given, I think. Yeah.
Okay, thank you.
Sir, there is a question in the chat box, sir.
Yeah, yes, madam.
How to repair a file? That question is posted in the chat box.
Yeah. Actually, okay. Just now I'm showing to you now. Okay, here, when we are doing the this hospital model, so a lot of errors are there. For that, we are using some mesh mixture software. Okay. That is an open source software. Suppose if you're having the magic software, in that magic software, you can do easily with this within 5 minutes, you can do it. But it is a commercialized software. It is costly. This is a mesh mixture is the open source software. We can download from the net. You can do here. But to repair the mesh to repair the STL file in the mesh mixture, it is taking some time. We have to do some manual operations. But when we are doing this one with using the magics, with so many options are available. Just you have to click it. Automatically, it will be repaired. And okay, you have to do some iterations. Within 5 or 10 minutes, you can do the repairs. I think if you are studying this CURA CK book 6 chapter, the STL file errors, might be the missing facets and gaps, all those things. Okay, that is, we are going to connect the lines, we are connect the triangles, then we can reduce the errors. That we are doing manually sometimes. Okay, some softwares are having automatically the options. The near neighboring methods, so many algorithms are there. Based on that algorithms, automatically it will be connect the lines and you can repair your STL files. Majorly, we are using the mesh mixture software and magic softwares. These two softwares we are using to repair the STL files. Good evening, sir.
Good evening, Chari. Are you able to hear me? Hear my voice?
Yeah, yes, sir.
So completed question and answers?
Yeah, yes, almost done.
Any participant still want to interact? Please give your feedback also about the session. I hope it was a very lively session. I know the expertise of Chari. And
CAD Civil is good or 3D Max is good and best suited for preparing and making the hospital type of prototypes. Actually, okay, we require the very intricate shapes. For that, we require the 3D Max software. Okay, in the architecture people nowadays, they are using the 3D Max software. Okay, we are prepared here we are deal on a project, a small consultant project we are taken. We are for that 3D hospital, what you are seeing in now. Okay, they are using the 3D Max software. And that automatic libraries are there. Okay, you are seeing very complicated shapes are there. Likely you can take and you can use. But if you want to do some CAD molding, it is taking some time. Okay, and it is difficulty. But we can get exactly STL files. But we don't bother about the STL file. We require the shape. Okay, nowadays we are going for the interior design team. Okay, that even nowadays we are using these STL files and this 3D printing. Even interior design people also they are using. but they are extracting very complex shapes. Okay, for that, okay, their own software, so many own softwares are there. That is best, okay, instead of our CAD model softwares. Niranjan, is it okay for you? Are you satisfied with my answer?
Yes, sir. Yes, sir. Thank you. Thank you very much.
Okay, thank you, sir.
Anyone want to give the feedback? Please switch on your video. Please, you can say a few words. Am I audible, Sweta?
Yes, sir. You're audible, sir. Sure.
Yes, sir.
Yeah. Any participant, I request them to give feedback if you on the session and you are know how you feel about the session. That is, I hope it's a hands-on practice. You had a practice on CURA and 3D slicer software. Already Chari has planned very well. He has given every material to us and we have sent you in advance. This session may be very helpful to you in future your research work, or you want to do some work on CURA software or using the 3D slicer biomedical applications. Chari, can we use 3D slicer other than biomedical application, other applications also?
Yes, sir. 3D slicer only it is a very good for the biomedical.
Only biomedical.
For biomedical, sir.
Any case of reverse engineering in that areas, for example, the image you may take a CT scan of a human being, but at the same time, can you take a scanning of any engineering object also? Can
Yes,
you
sir.
do the slicing 3D? That is like using a CT scan. So nowadays, some CT scan are these are used even for scanning the engineering objects, not only.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
So in that case,
Yeah.
can you use the 3D?
Nowadays, okay, we are using some entity testing purpose. So we are using the micro CT scanning.
Yeah.
Okay, whatever the holes or porous structures are there, any impurities are there inside of the casting. Okay, for that, okay, we are going to do some scanning, the micro CT scanning. Up to micro level, we are going to scanning. Even up to micro level, we can check each and every layer. There might be, sir, okay, when we are doing the scanning, we are getting so many layers. Okay, based on the layer thickness, we can extract so many number of layers. In each layer, you can inspect. Okay, that type of techniques nowadays they are using in the mechanical engineering for the NDT testing. For that purpose, nowadays they are using the 3D scanning techniques as well as this 3D slicer softwares.
GT, what is that scan? CT scan, right?
Yes, sir. Micro CT.
Micro CT scan for
Micro
defects,
CT.
identifying the defects.
Identifying the defects in casted object or in the welded objects or anything.
So in that case also, this 3D slicer can be used.
Yes, sir. Yes, sir. Yeah. Anyhow, you have to extract the CAD model. The CAD model we are going to look at in each and every layer.
Yeah, correct.
So
this is another application. The 3D slicer not only for biomedical. You can do like this. I hope in the next future FDP will do that also. We'll change somewhat biomedical plus this one also.
Okay, sir. Yes, sir.
Chari was regular to our FDPs and he was very enthusiastic. And above all, I would like to say he's my best student so far I had. He has done MTech and done project under me.
Yes.
Just I want to brief about him. So what one can achieve. So he's a person who is very hardworking, sincere. Just to tell you how you can reach to a certain level if you are sincere and hardworking. He's the first person who I think has done biomedical modeling on SLS machine, right?
Yes,
his application.
Yes, sir.
So what is that year is, Chari? 2010 or?
Yes, sir, 2010, sir. 2010.
2010, 9-10. So
Yes,
he approached me and we both thought we'll go for biomedical applications. And when he presented his final thesis, the examiners from NIT Warangal, I think some of the NIT guys are also there in this workshop. So he asked Chari, he was surprised at the time. So doing a biomedical mechanical student and explaining all those things. And I think it was overall maxillofacial.
Yes, sir, oral maxillofacial.
Oral maxillofacial. And he was awarded. The examiner asked Chari that you please publish a paper. He sent him. So immediately he got degree with excellent grade in MTech. And after the MTech also, the interest that he has shown that he want to publish a paper, I think he has done another case study to publish a paper.
Yes.
Case study. And we submitted the paper and I think we got initially 60 questions. and we answered all of them. And that was a very big experience for us, because the first time we are doing 3D printing, that too biomedical. And then it got published, I think after 1 year, almost after 1 year. So see the perseverance of him. It's not to tell that boasting, but it's a real fact that one can achieve. And finally, he was called by CUA, the Singapore Nanyang Technological University, to present in a conference as a like a speaker, right? As a, I think you went there, and before going there, he came. At that time, he was doing PhD in NIT Warangal. Because of that publication of paper in that journal, he got admission in PhD in NIT Warangal. I hope that is true, Chari. That helped you a lot.
Yes.
So, and that was still that has got a lot of citations. If you see our Google Scholar, you can see that paper has got a lot of citations. And he was called by CUA in his bioprinting conference in Singapore. So to that level he went. So, and I think his PhD work was very well run, and he applied for patent also on that one.
Yes, sir.
And he has given some life to a girl, the result of his PhD work. That is the greatest thing.
Yeah, people the TNA
I think he felt very happy than his PhD award certificate. That girl approached him and told, "Sir, throughout my life, I was unable to eat, but because of your PhD result, I got." That should be the PhD work. That should have some social meaning. And from that onwards, even though he completed almost 10, 11 years back, we are in touch, and we work together. And I really appreciate his growth, and I feel proud as a teacher that one of my students has done excellently well. And I hope today you might have all enjoyed his session, practice everything. And he can do more than that. I hope any participant, you can share your experience of this session. Have any more questions you can ask? Otherwise, we'll wind up the session.
Sir, good evening, sir.
Sir Srinivas, welcome, sir. Welcome.
This is very good information session, sir. Very nice session by Manamadachari Garu. And one more thing is, when a raw student comes into your hand, you make them as a marble or golden marble, sir. So that is the advantage of you, sir. That is the greatness of you, sir. That's the reason why you mold an ordinary stone into a good idol, worshipped by so many people. So now you have changed him to that extent, and we could able to hear your voice through him, sir. We are very fortunate enough to have Manamadachari's lecture today, sir.
Okay,
very
excellent.
excellent.
Thank you.
Very excellent.
Actually, this is my voice actually, but my voice is represented by the.
I am giving on behalf of you,
Yes,
sir.
sir. Yes, yes, sir. Yeah, exactly.
So I know him, Sivaram Krishna sir.
Yes, sir. Yeah, exactly. Yeah, yes, sir.
So he will not leave the student. He mounts to his capabilities, and he makes them to learn, and he will make them to shine in the society, sir.
Yes,
I have seen him.
Yeah, that is a truth. That is a truth, sir.
On this platform, I'm praising.
Actually, because of him, I entered in the biomedical field, sir. Actually,
very nice,
sir is insisted you have to do this topic. You have to do research in this topic like that.
So he is doing innovative projects also, sir.
Yes, sir.
After taking up this 3D printing, so he is doing a lot of service to the society as a mechanical engineer, because mechanical will be limited to the four walls. Now he has come out, and then he is making or doing miracles in the biomedical engineering, interacting with doctors, and doing a very good job to the society, sir. This is very much essential from the engineering point of view, especially mechanical. So I'm very happy to see you, sir. Thank you. Thank you, sir.
Thank you, sir.
Thank you, Srinivas, sir, for your valuable words. This is our responsibility to make our friends. I feel I have not done so great thing, but only my duty I have done. Yes. But sometimes may be harsh to the students during their project work. Okay. But few students will understand that, and they become like diamonds, as you said. So it is their interest. My guidance may be there, but their interest is also very important. In that category, I rate Chari as #1 in that. So because even after 10 years, he got everything. PhD, everything is done. So PhD also admission he got, and he has done PhD under my.
I'm happy to note that he got admission through the paper published by him.
Yeah. I think at that time that NIT director got surprised when he was taken interview, PhD interview. that you are mechanical, you are done. Even in NIT at that time, very people have, no one has done, I think, in biomedical side.
Sorry, the 2010 actually this 3D printing, the biomedical is very, very new topic on the days, not now.
On that, right. That is 10, 11 years back.
10 years back.
15 years back.
Even
And
after 10 years,
I asked Chari sir, I want to tell you one great quality of Chari is, when
Okay.
you are going to PhD, you might have told me, because I know many people in NIT, I would have told your name recommended, but he said, sir, I should get seat on my own with my own effort. That is the thing.
That should be the spirit, sir, as a student. Okay. Very good.
Thank you, Srinivas garu. Very senior professor from CBIT. Nice to hear words from you.
Thank you, sir. Thank you.
I also appreciate your interest. Even you are a very senior professor, you are taking out time and attending all the sessions, maximum number of sessions. I request all the other participants also, you are very new. I have seen a lot of young people, assistant professors, but you are not attending. Sir, you can see some of the senior professors like Balachandra garu from Tamil Nadu, from Shastra University. He's a very senior person, sir. He's also attending regularly every session. And I appreciate I request everyone of you. The Atal AICT is providing a nice platform to us. So it is a free of cost. You can sit anywhere, you can do work and you can listen and you can attend.
Yes.
So we should all thank AICT, in fact, for providing such a wonderful platform to all of us. So can you imagine so many people coming at a time, and we expert they are moving the expertise to your home. Move the expert without move the expertise without moving the expert.
Yes.
So that's the concept of AICT. They are moving the expertise without moving the expert, and we are all fortunate to listen to them. So you please, you all registered means you are serious. I asked them 164 people confirmed. You all confirmed, so you should be serious. At least I was telling, out of 9 sessions, at least you should attend. Out of I am not telling entire session, at least some sessions. We are arranging the sessions in such a way. I hope sir might be seeing our schedule. So every session is very interesting session. We are calling doctors. So you never get such kind of opportunity. The morning 2 doctors are very, very busy doctor. Professor M.V. Reddy garu is very senior.
Has an excellent deliberation, sir. That was
Very
very
senior
good.
doctor, and one famous Guruva Reddy garu. He works with Guruva Reddy garu. And he is so enthusiastic academic. I got the opportunity to work with him and have a coordination. Whenever I call, he said, ready, Shivaram, I am ready to present. So you should all use that facility. And he's ready to provide a lot of work to our engineers also. Like Abhinandan sir, he's a very young guy, but he has got trained in China everywhere. So he works on 3D printing a lot, maxillofacial, very famous doctor. But we should all listen to their lectures so that some of you can work in that direction. Tomorrow's sessions will be also interesting. Morning first session will be how to make your own 3D printer. Very interesting from Rakesh. Think 3D Rakesh is coming out. Very practical man. And the next session is our 3D printing man of our Usman University, Professor Sriram Venkatesh, will be taking you journey of, because he is busy until today convocation. Today morning I am also not present for the magazine session because I am in the convocation ceremony. We are having duties. So we are doing multitasking. So I have given live from that convocation only, M.V. Reddy, all those people. So tomorrow I think Professor Sriram Venkatesh will be talking about prototyping to the product, how rapid this 3D printing can be used. And last session is a very senior professor from IIT Delhi. So you should all think that how much efforts we are putting to make all these people come together. Getting a professor from IIT Delhi, Professor Pandey, is very senior, top man in the 3D printing. He was the initial, like Dr. U. Chandrasekhar, he is also first few people in India who started working on 3D printing. And for approaching him, it took so many days and getting his appointment. So tomorrow he will be coming and presenting. So I request all of you, please attend, don't miss those sessions. And day after tomorrow also you are having demo sessions, and followed last session is a very interesting from Tata Motors head coming from Pune. And at least I request all of you, you reach 164 people. So please try to attend the remaining sessions. We are getting good response only. Every session average we are getting 100. But I feel whatever the remaining 40, 50 people, please try to attend. This is a very good platform provided by AICT. Please use it to the maximum extent.